In our last video, we talked about 4 different types of reflection. We had our reflection in y equals x, and then we spent a lot of time on reflection in the y-axis, the x-axis, and the origin. And we talked about the fact that anything that affects your graph horizontally is going to affect your x values, your input. So you'll replace your x with, in the case of reflection, negative x. Whereas any sort of vertical change to the graph or to the function is going to affect your y value. So whatever you do to the function is going to affect the whole function. If you remember, one of the things that I said is that this is true for all transformations. So it is. So let's start talking about translations. So what is a translation? It's a type of transformation. It moves the location of the graph. So if you think about a circle, it takes the circle and it moves it from one end of the page to the other end of the page. Okay, so it moves the location of your graph. We talked about rigid versus non-rigid transformations. This one is a rigid transformation. Remember, a non-rigid means that the shape changes. Here, it does not change the shape. It only changes the location. So we have 4 different types of translation. We have up, down, left, and right. If you move in any other direction, you're moving on a diagonal, which means that you're doing some sort of combination of up and left, or down and right, or down and left, or up and right. So here, we're only going to look at one of them at a time, and then it might be that you're doing more than one, okay, which we'll get to in a later video. When we start combining, we might do a couple in this one, but not a lot, okay? So let's start with up. And I want you to keep in mind that what we do to the function very much reflects what we do to the points. But there is a slight inconsistency in this in translation with respect to translating a point versus translating a graph, and that has to do with when we go right or left. So unlike in reflection where I said, okay, well, a point x comma y becomes x negative y, we're not going to do that here. We're going to go with intuition. In other words, what appears to be correct is kind of correct, okay? So if we're going up, on a graph, it makes sense that what that means is we add to the y values, right? On a graph, going up has to do with the y-axis, our y values. Up means that we increase, okay? So we're adding to the y value. And for the purposes of what we're doing here, we're going to try and keep everything general. We're not going to say we're going to say that we're going up by c units. C being a constant, it can be any number, okay? It works whether we say we're going up by 3 units or we're going up by 10 units, okay? So if we move up by c units, that means that we add c to f of x. Remember, f of x is our y. It's just telling us right away that our y is a function. Okay. okay? So we are adding to the y. So in other words, what we're saying is f of x becomes f of x plus c, because we're adding c units to the y. Okay, so let's do exactly what we did with reflection and take a bunch of different types of functions, like we did the last time, and show what happens when we take this function and we translate up. But instead of just using c, let's actually use a number, okay? So let's suppose that c is equal to 3. And what we do with the number 3, we could do with any number. We could suppose c is 100 or c is 50. We're just going to keep c as positive, okay? There's no reason to make it negative. Negative would essentially say that not only are we moving up, but we're also reflecting in the x-axis, and there's no reason to combine those right now, okay? So we're going to suppose c is equal to 3. And what we're going to do is we're going to move each of the following. I'm going to change this word move to translate. Let's be mathematical about it. So we're going to translate each of the following up 3 units. Okay, so again, let's just take a list of 5 different functions, and we'll take each of those and translate them up, just like we did with reflection. So let's say that we have a linear function. Let's say that we have a quadratic function, which is essentially, it is a polynomial function. Let's take the example of an exponential function, a logarithmic function, and let's do an absolute value function again. And the reason why I'm giving you all of these different types of functions is that I want you to understand that what you do for one function is exactly the same as what you do for another function. So we're going to translate each of these up 3. I'm not going to show you the notation yet for translation. We're going to do that a little bit later. That does not look like an up. Let me fix that. Okay, we're going to go up 3 for each of these. And I'll show you the notation at the end. It's not that it's complicated, it's just that most of our translations are a combination of 2 different directions. So I want to show you what the notation looks like because at the end, because the notation talks about a combination of 2 different directions. Okay. So for translating up 3, then instead of f of x, we're saying, okay, we'll do f of x plus 3. I'm just going to put this in a different color so that you can easily see what the translation is. What's the translated function? So in each of these, the new function notation is f of x plus 3. And you should know the function notation because the function notation helps you figure out how to change the actual function, like the 2x plus 6. So if you remember from reflection, when we're affecting the y, essentially what you're doing is you're taking your original function, you're putting it in parentheses, and then you're adding 3 to it. And this is true for all of these, all the way down. You're doing f of x plus 3, so you're taking your original function and you're adding 3 to it. And I'll stop here, because the others will start from scratch. So what's our f of x? What's going inside this set of parentheses? Well, here our f of x is 2x plus 6. So 2x plus 6 is what goes inside this parentheses. And sure, of course, we could simplify this. This is easy enough to simplify. You won't always be simplifying. Okay, sometimes you're going to say it's not worth it. Let me wait to simplify. It can be done at the end. And sometimes you're going to say it's easy enough to simplify and get rid of parentheses, so why don't I do that? And that's really going to depend on whether you're doing one transformation, whether you're doing multiple transformations. It's very dependent upon that, and also dependent on the type of function. Okay. So here, what's going inside the parentheses, where our original function is 3x squared plus 7x. And then we're just adding 3. So again, here the parentheses actually don't do anything for us because it's addition. Here, what's the original function? The original function is 7 to the x minus 4. So it's 7 to the x minus 4 plus 3. And I'm just going to rewrite this portion only because in terms of handwriting, it's important that that plus 3 doesn't look like it's part of the exponent, and it kind of did. Okay. Okay, so let's take the next one. Again, nothing changes. I just wanted to do this one from scratch. I do strongly recommend that at this point you pause the video, you try these two yourselves. Okay. So once again, this is f of x plus 3. The notation doesn't change just because the function changes, because the f of x represents any function. And then we just have log of 6x plus 8, which is our original function. And we put a plus 3 on the end. And that's it. You're not simplifying this, okay? You cannot combine these because one, you're taking the log, and the other, you're not. This is order of operations. We have to take the log before we add 3. Remember, log in order of operations would be the same as exponents. Okay? So we just leave it as log of 6x plus 8 plus 3. And same thing down here for our absolute value. F of x plus 3. Remember, we don't really need parentheses here because the absolute value sign acts as parentheses. So this would just be absolute value of 6x minus 5 plus 3. Once again, we can't combine these. Okay, absolute value has to come before addition. And if you think about it, it kind of makes sense. If x were a negative number, okay, it would make sense that taking the absolute value of 6x minus 5 and then adding 3 to it would potentially make a difference rather than doing 6x minus 2, okay? The absolute value of 6x minus 2 says that for certain values of x, we're going to create positive numbers before we're ready to create those positive numbers. Okay, taking the absolute value of 6x minus 5. Remember, absolute value gets rid of the sign. We don't want to get rid of the sign too early, okay, or too late. We don't want to be adding. So in other words, absolute value acts like a parentheses. Since absolute acts like a parentheses, you have to do what's in the parentheses first. And let's actually do a reciprocal function, a rational expression. I didn't include that, but it doesn't really change anything. If we had f of x equals x plus 2, over x squared minus 8. Nothing changes here. You're still doing f of x plus 3. So we're taking the function x plus 2 over x minus 8. And we're adding 3 here. And to combine this, you would need a common denominator. And we're not really talking about the algebra in this video, so we're not going to take the time to actually do that. Okay, but you would need a common denominator. Okay, so this is if we translate up 3 units. Let's change this. Let's say that we're translating down 3 units. Let's do this one in purple. Just that you know that it's a different translation. So we're going to translate each of the following. Let me actually change this. This will eventually be in your notes, but let's actually write what a translation down first is. So if a translation up says that we add to the y value, then a translation down says that we subtract from the y value. Up and down are opposites. So if we move, in this case, we're going to move down C units. So we're subtracting C from f of x, which is our y, which means that f of x becomes f of x minus c. Okay? Before it was addition, now it's subtraction. So in this case, let's translate each of the following down by 3 units. So in other words, C is equal to 3. So we're going to do the same thing. We're going to take the same functions, same six functions, and we're going to translate them down. So we have f of x equals 2x plus 6. We have our linear function. We have our polynomial function, 3x squared plus 7x. We have our exponential function. Notice the x is in the exponent. 7 to the x minus 4. We have our logarithmic function. Log of 6x plus 8. Notice this 6x plus 8 is in parentheses, so you're taking the log of the whole thing. We have our absolute value function. And we have our reciprocal function. Okay, and in each of these, we're going to go down 3. So once again, what you're doing is you're taking the whole f of x, you're putting it in parentheses, and you're just subtracting 3. And in some cases, you don't need parentheses, but if you're somebody who's really not sure, then put in the parentheses. Okay, so f of x minus 3, and let me just put in all of our arrows so that we don't have to do it later. And you should all be able to stop the video at this point and do this, because once you know how to do up 3, down 3 is really simple because it's just the opposite. So f of x minus 3 says you're taking your whole function, you're putting it in parentheses, and then you're subtracting 3 from it. So what's our whole function? 2x plus 6. And again, this is easy enough to simplify, so we may as well. 2x plus 6 minus 3 becomes 2x plus 3. Same thing for all of these. It's always going to be f of x minus 3. Our function notation is always the same, regardless of the type of function. So here, what is our function? Our function is 3x squared plus 7x. And then we just subtract 3. And again, here, the parentheses make no difference because we just have addition and subtraction, and it's always going to be right to left. Okay. For our next one, again, f of x minus 3. You don't need to put your function in parentheses, but you absolutely can. 7 to the x minus 4 minus 3. And if your handwriting is not that great, like I don't have the best handwriting, and you're not sure whether that minus 3 is part of the exponent or not, right? Like the last time with going up, I erased it and I said, okay, it kind of looks like an exponent, so let me erase it. You can do one of two things. You can either put the whole thing in parentheses like I did here, right? I put the whole 7 to the x minus 4 in parentheses, and that made it really clear that the plus 3 was not part of the exponent. I'll do it a little bit differently here. Your other choice is to put just the exponent in parentheses. Either way works, okay? The other way, honestly, is probably better, because theoretically the minus 3 could still be part of the exponent. So the other way is probably better, but if you have good handwriting, and as long as that minus 3 doesn't look like it's part of the exponent, it makes no difference. You don't even need the parentheses. So then we have f of x minus 3. Our function is the log of 6x plus 8. And then we're subtracting 3 from that. F of x minus 3. Our function is the absolute value of 6x minus 5. We're subtracting 3 from that. Notice we can't do any sort of combining here because of order of operations. And then here, f of x minus 3. X plus 2 over x squared minus 8. And then minus 3. And here, if you wanted to combine, you would need a common denominator. And that's it. Okay. Moving up and down is really, really straightforward. Okay. Moving right and left is also pretty straightforward, except for one small thing. So let's go to moving right. And just like up and down, once you know how to do one, you know how to do the other. So if you know how to move up, you know how to move down. If you know how to move down, you know how to move up. The same is obviously true for right and left. If you know how to move right, you know how to move left. If you know how to move left, you know how to move right, because it's just the opposite. So let's do right first. So this is a little bit counterintuitive. So this is the place where you need to be careful, okay? So up and down, you're adding or subtracting to the y. Left and right, this is a horizontal change, which means that you're adding and subtracting to the x, okay? The thing that's counterintuitive is that when we move a point to the right, we add to the x value. When we move a function to the right, we subtract from the x value. So this is the tricky part here, is remembering that instead of adding to the x value, we're subtracting from the x value. And after we go through right and left, I'll show you why that's the case. But it is the case, so just be really, really careful, because that's where you could mess things up. So here, that's the only thing that makes this tricky. Everything else is exactly the way that you would picture it. So we subtract from the x. So what does that mean? That means if we move to the right by c units, we subtract c not from f of x, but we subtract c from x. So that means that f of x becomes f of x minus c. And this is just like composition of functions. Every time that you see an x, you're replacing it with x minus c. Okay, so this is the same thing. Let's, for each of the following, let's translate it. Let's translate each of the following to the right by 3 units. So in other words, c is equal to 3. So we're going to do the 6 functions again. F of x equals our linear function 2x plus 6. F of x equals our polynomial function 3x squared plus 7x. F of x equals our exponential function 7 to the x minus 4. F of x equals our logarithmic function, 6x plus 8. F of, I don't know why I wrote 6. I was thinking ahead. Then we have f of x equals our absolute value function, absolute value of 6x minus 5. And finally, f of x equals our reciprocal function x plus 2 over x squared minus 8. And we're going to move each of these to the right by 3. Okay, so this is just like a composition of functions. You're replacing every single x with x minus 3. So we have our, so these are all going to be f of x minus 3. Again, you could try this on your own, or you could stick with me for a couple of them and then pause the tape and do it on your own. Okay. So once again, every time that you see an x, you're going to replace your x with x minus 3. So here's our x. So instead of writing 2 times x plus 6, we're going to write 2 times x minus 3 plus 6. And you could simplify this, okay? This is easy enough to simplify. You can distribute the 2. You get 2x minus 6 plus 6, which is just equal to 2x. I won't ask you to, most of the time I won't ask you to simplify it. It's just that if I'm having you do multiple transformations, it's possible that it could make things easier for you. Okay, let's do the next one, f of x minus 3. So remember, this is saying every input should be moved to be replaced by x minus 3. So we have 2 inputs here. We have this one, and we have this one. So we have a 3, and instead of x squared, it's going to be x minus 3 squared. And then we have a plus 7, and instead of x, it's going to be x minus 3. Okay, and here again, there's no great purpose in simplifying, so unless I asked you, you don't have to. I'm not testing your algebraic skills right now. Here we have an x. We're replacing it with x minus 3. So notice this says take your x and replace it by x minus 3, right? We have our f of x. Replace your x, only your x, with x minus 3. So here, this becomes 7 to the x minus 3 minus 4. So this might be a case where you might say, hey, we should just simplify. It's easy enough. Okay. Then we have f of x minus 3. Here's our x in our original function. So it becomes log of 6. Put your x minus 3 in parentheses, okay? And you can simplify this. You don't have to. You would distribute the 6 and then, add 8, but you don't have to. F of x minus 3. And this one, the x is over here. So the absolute value of 6, x minus 3 in parentheses, it matters. Minus 5. And then finally here, once again, you have 2 x's that you're considering, so replace both of them. This becomes, instead of x plus 2, it becomes x minus 3 plus 2. And admittedly there, the parentheses are not necessary, but in most cases they are. So if you're not sure, stick them in there. And then over here, instead of x squared, it's going to be x minus 3 squared plus 8. Okay, so that's a translation to the right, which means to the left, it's pretty much the same thing, right? The only difference is that, again, counterintuitive, for points we would subtract, but for functions we add. So if we move left by c units, we add c to x, which means f of x becomes f of x plus c. So once again, we're going to just translate each of the following. To the left by 3. Meaning we're going to say that c is equal to 3. So we're going to go through each of our 6 functions, same 6 functions. Our linear function, our polynomial function, our exponential, our logarithmic, our absolute value, and our reciprocal. And again, now is a great time for you to pause the video. Just do each of these by yourself. Here we're going to the left by 3. And our function notation is always going to be the same because it's independent of the type of function that we have. And all we're going to do is we're going to replace all of our x's. Instead of with x minus 3, we're going to replace it with x plus 3. So here we replace the x in 2x plus 6 with 2 times x plus 3 plus 6, which in this case, just that you see the difference, you get 2x plus 6 plus 6, which is 2x plus 12. Again, you don't have to simplify, but this is easy enough. In this one, we have 2 x's. Both of those x's are being replaced with x plus 3. So we have 3 times x plus 3 squared. You have to square the x plus 3 first. So you can't, this is algebra to go and simplify this. Okay, you can't distribute the 3 first. You have to square the x plus 3. Here, the x is in the exponent. F of x plus 3 is 7 to the x plus 3 minus 4. And again, this is easy enough to simplify. This becomes 7 to the x minus 1. Here, f of x plus 3 is the log of 6 times x plus 3 plus 8. If you forget to put it in parentheses, then you're saying only the x gets multiplied by 6, but the whole x plus 3 has to be multiplied by 6. Same here, f of x plus 3 is the absolute value of 6 times x plus 3 minus 5. You have to distribute that 6. And there are 2 x's here. So both x's need to be replaced. If you had 10 x's in your function, all 10 x's need to be replaced by x plus 3. You can always choose to simplify, but a lot of the time it's not necessary. The only time you have to is when I tell you to, or if you want to do it because it makes things simpler for you. Okay, so 2 other small things. We're going to talk about the y for the left and the right. Why do you subtract? Why do you add for left? And then we're just going to talk about notation. Okay, so why do we add to x when we go to the left, but we subtract from x when we go to the right? Okay, I'm going to do the best that I can, okay? Obviously, this is a lot easier to explain in person. The best way that I can explain it is that we're no longer looking at where we're going, we're looking at where we came from, okay? So I want you to think about it like this. Let's say that we have a person standing here. Here's my beautiful person, okay? And we're going to move this person 3 units. Let's say 3 units to the left. So I'm going to change the location of this person. We're going to put this person here, okay? Well, this is our new x. Sorry, I'm going to change the colors here. Okay. We want to move this person 3 to the left. So here's the person. And this is our new x value, okay? Now here's the thing. The 2 people have to be the same height, okay? So these people are the same height. same height because it's the same person. So think about this, okay? Think of yourself. You take yourself and you move 3 spaces to the left. And you want to know, well, how tall is this person, okay? Well, in order to figure out how tall the person is at that particular point, what we need to do is we need to look to the right to see where you came from. So in other words, let me change this scenario just a little bit because obviously you know your height. Over here, some person is, we could even say on their knees, okay? And we take this person and we move them 3 spaces to the left. Now we don't want to change their height at all. The height represents the Y value. Again, this is much easier to explain it in person, so I apologize if it doesn't come out perfect here. We take this person, we move them 3 spaces to the left. That's our new X value because we're talking about our new function. That's our input, okay? We don't want to change their height though, because all we're doing is we're moving them 3 spaces to the left. We're not changing the Y values at all. We're only changing the X values. So if we want to figure out what their height is, what we need to do is we need to look at what happened before we moved them. So we're turning to the right in order to figure out their height. So we're looking at where they're coming from as opposed to where they're going, okay? So to determine their height, we need to look to the right to see what their height was then. Okay. In other words, what we're doing is we are looking at where we came from versus where we're going. Let me create a graph. Let's look at a graph to look at this. Let's say that we have x minus 2, okay? If we translate this to the left by 3 units, we're replacing our x with x plus 3. Okay, this is our new graph. I'll do the best I can with this. If we take this point right here, okay, and we translate it to the left by 3 units, what we're doing is we're taking our x value and we're moving it to the left, but in order to determine the y value, we need to look at where the y value was 3 units to the right. If we take this point and we translate it 3 units to the left, in order to get the right y value, because we're not changing the y value, we have to look at what the original y value was, which was what the value was 3 units to the right at x plus 3, right? If we want to figure out what the y value is at x equals 2, then in our original function, we want to know what the y value is 3 units to the right at 5. So that's why we're adding the 3. Because we're looking to the right, we're looking at what the y value was 3 units to the right, which would be at x plus 3. If we take x equals 7, we want to move it to x equals 4, but in order to find the y value, which is f of, what we're doing is we're looking at the y value of f of x plus 3, Okay, so that's what's really happening is we're saying, okay, well, the y value for 4 is going to be what the y value was in the original function at 7, which is x plus 3. Okay, so let's just write that down. When we move three units to the left, to get our new y value, we have to look at the y value of the original function that was 3 units to the right, or at f of x plus 3. Okay, so when we go to the left, we add, and when we go to the right, and going to the right is the same thing. Once again, if our original function is x minus 2, then when we move it to the right, we're moving it to the right by doing x minus 3. If we take this value on the blue graph and we move it 3 spaces to the right, so going from x equals 2 to x equals 3, in order to figure out what the y value was, we have to look at what the y value was on the original function, which was 3 spaces to the left, or at x minus 3. Here at x equals 5, our new x value is x equals 8. In order to figure out the y value, we have to look at what it was at x minus 3. So 8 minus 5 at x equals 5. Okay, so that's why we do that. Okay, the last thing is notation. So the notation is a capital T for translation, and then a C, comma, D. Okay. So the notation, the C, comma, D, is the same as it would be for points. What do I mean by that? The C is the change in the x value. So this is the translation right or left. Okay, and if C is greater than 0, we go to the right by C, because we're like adding. And remember, it's for points. And points we would add if we're going to the right. So we go to the right by C. So this is the opposite for the function. And addition means that you subtract. It would be f of x minus c. Okay? And if c is less than 0, then we go to the left by c. Which means that we're doing f of x plus c. Okay. The D is the translation up, down. And this is the same. So it's only the C that can be confusing. Okay, so if D is greater than 0, that means we go up by D, or f of x plus D. And if D is less than 0, we go down by D, or f of x minus D. Okay, and let's just do some really basic examples here. I'm going to run through these relatively quickly. Please try it on your own. Okay, so let's say that we have f of x equals 2x squared. Okay, and we want to translate, this is our notation, 3, negative 5. So what does this mean? This is a translation. 3 to the right, down 5. Okay, here's what that means. That means that our x's are being replaced by x minus 3. So notice this is a positive 3, but in our notation, it's an x minus 3. And then we subtract 5 at the end. So we can do both of these at once because we have one vertical and one horizontal. They really don't affect each other. So this says take all of our x's, replace them by x minus 3. So our x is 2x squared, so it becomes 2 times x minus 3 squared. And then subtract 5 at the end. And that's it. Let's say that we have f of x equals log of 3x plus 1. And this time we're translating negative 2, 4. So what does this mean? A negative 2 tells us we go to the left. And a positive 4 means we go up. Okay, so to the left means our x gets replaced with an x plus 2. And we just add on a 4 to the end. Here's our x. So let's do that first. Our x gets replaced with an x plus 2. That's the movement to the left. And then we just tack on a plus 4. We'll do 2 more. F of x equals 3 to the 6x minus 4. And this time we're going to translate 1, negative 6. So what does this mean? Always identify your translation first. This tells us that we go right by 1 and down 6. So right by 1 means that we subtract 1 from our x. Down says you just subtract 6 at the end. So we have 3. Sorry, I put that parentheses in the wrong place. We're going to put the parentheses out here because we know that we're going to take our whole function and subtract 6 from it. Here's our x. So it becomes 6. That x gets replaced by an x minus 1, minus 4. This is our whole function, and we just subtract 6. And that's it. Okay, so it's done. You can stop the tape here. It may take me just a second to stop the tape myself, so you can just stop here.